Hi everyone, I'm happy to present the results of a preliminary analysis of our research. I have nothing to disclose. We know that urine leakage during physical activity is a barrier to exercise for a lot of females out there, and many of them will limit their physical activity due to it. There are competing hypotheses in the literature, and while some studies suggest that high-impact activities such as running is harmful, others suggest that physical activity might be a protecting factor for urine leakage. Therefore, the goal of our study was to shed more light on the mechanisms associated with stress urinary incontinence during running by investigating the differences in pelvic floor morphology and function between female runners with and without running-induced leakage, and to compare the effects of an acute bout of running on those properties. This is an ongoing cross-sectional study, and we recruited experienced female runners into two groups: female runners that regularly experience SUI while running and female runners who do not. Unfortunately, recruitment has been on hold since March because of COVID-19. We collected demographic information and questionnaire data, such as the IPAC and the ICIQ flutes. We used an intravaginal dynamometer to evaluate the pelvic floor muscles of the runners during a maximal voluntary contraction of their pelvic floor in standing and during passive tissue elongation in supine. We also used 3D ultrasound imaging in a standing position to obtain a static volume of their levator hiatus. Then the women completed a running protocol that was around 37 minutes long, and we repeated the evaluation of their pelvic floor muscles using intravaginal dynamometry and ultrasound imaging. Our outcomes of interest were the area of the levator hiatus at rest. We calculated the relative peak force during the MVC and during passive tissue elongation. We also estimated the power of the pelvic floor muscles by calculating the rate of force development during the MVC and stiffness during passive tissue elongation. The stress relaxation response while the arms of the intravaginal dynamometer remained open for 7 seconds was measured using the coefficient of the decay function. We performed normality testing on all outcomes and used a mixed effects ANOVA to compare the outcomes between groups, so between runners with and without leakage, and across time, so before and after the acute bout of running. We also calculated the effect sizes and power for each variable. Both groups were similar for all demographic information of interest. The only significant difference was in the ICIQ flute score, which was higher in women with SUI as expected. If we take a closer look at the results, we did not find any significant two-way interaction between continence status and timing for any outcomes. However, when doing the post-hoc analysis, we did notice a significant difference between female runners with and without leakage in the stress relaxation response during passive tissue elongation, and a significant change after the run for both groups for the remaining outcomes. Interestingly, we noticed a significant small increase in relative peak forces after the run during the MVC for both groups. We also found moderate effect sizes for the interaction between continence status and timing for the levator hiatus at rest and standing and relative peak force during tissue elongation. What is interesting here is that relative peak force during passive tissue elongation increased after the run for female runners without SUI, and it significantly decreased after the run for female runners with leakage. To date, there is no indication of a significant interaction between continence and timing. However, given that our power ranged from 82 to 93% for 4 out of 6 outcomes, significant findings may emerge after reaching our target sample size of 25 runners per group. Given that we did not find any significant difference between groups for the outcomes during the maximal voluntary contraction, at this stage there seems to be no indication of pelvic floor muscle strength between groups, and pelvic floor muscle fatigue appears to play a limited role in running-induced SUI after the run. The moderate effect sizes for the interaction between continence and timing for the relative peak force during passive tissue elongation suggest that passive changes in the properties of the pelvic floor muscles and surrounding connective tissues might play a role in running-induced SUI in experienced female runners. Given this finding, repetitive loading during running might have implications on the support offered to the pelvic structures. We are hoping to reinitiate recruitment as soon as we are permitted to do so. Thank you so much, and make sure to follow the McLean Lab on social media for updates on our research.